Konnichiwa, Zamurai Engineer this. In this video, let us continue module number 11, and this video particularly will discuss about placing exit closer. So, what do you mean by that? It might give us several opinions about this, so let us proceed to the video and explain what it is really is. So let us proceed, starting with the code objective that specifically it is its goal is to minimize danger to life from fire, smoke, heat, and toxic gases. It provides mission continuity and property protection in new construction in existing buildings. So still we are in module number 11, options and travel path disruptions for common path of travel. And we are now on the third subtopic, bring exit closer to occupants. So there are situations because of the provision and requirements, minimum requirements of the code to have the limit on the distances, okay? And therefore, in our design, we must formulate an arrangement wherein we can bring those exits closer, more closer, so closer to the occupants. And it is always better if we place those exits closer to occupants, because they can what? They can take advantage of it, and therefore they can get out of the building easier, faster, and probably unharmed. So extending the exit stairs required enclosure to include a portion of the corridor creates an exit passageway that brings the exit closer to the occupants, as in this picture. In this picture, we have exit passageway, okay, used to keep travel distance from becoming excessive. So that is our main problem actually as a design engineers, building design. So we must check and evaluate if our travel distance is now over the limit of the values provided, suggested by the code. So from position X, this is the remotest, okay, the remotest point inside this room, inside this particular room, going outside to the common path of travel, to this passageway, to this point, okay, would be what? Would be shorter if compared to the same starting point going to E2. So compare the distance going to E1 and going to the E2. Of course, you can easily observe visually that X to E1 is shorter, and therefore it is better design. So therefore, what can we do? How can we make it to E1 as a design fire protection rather than E2? Because naturally, X to E2 is the natural travel path. So the distance from X to E1 is within the allowed travel distance, okay, assuming extension of an exit stairs enclosure is often used for travel distance to an existing enclosure would otherwise be excess of code allowance. Because it is an exit passageway qualifies as the point at which travel distance measurement ends. This is the correct technical explanation. Okay, so in the previous videos, I explained that it is considered now as the exit, wherein that point is now discharging to the outside of the building. Not directly, but in the same safety level. Because of the same safety level and the same condition that exists from point E1 to point E2, the same safety level that you can experience on this exit area. Therefore, this exit area extends up to this point so that our distance of travel is now shorter, because an exit passageway, this is an exit that would qualify as the point at which travel distance measurement ends. So we start our measurement here, and our measurement will end in E1. So meaning to say, it would later on satisfy the requirement of the code. So it is what? In accordance with section 7.6. So that's all with the concept and principles involving techniques option that would give us the way or means to make the exit closer to the occupant. In that case, we did not change the exit openings, but we changed the material that would enclose the passageway, so that the end point of the passageway is now qualified to be on the same degree of safety as the actual exit. With that concept, this is your professor, Dr. DrEYPEI, Preaching Engineering Coordination Building.